Solar gain is a fundamental principle of building an energy efficient house, whether it is building to Passive House standard, to NZEB Nearly Zero Energy Building Standard, or to the Interfit Passive House Retrofit Standard. These construction methods utilize the sun's energy to provide light and heat to create a comfortable interior environment for a dwelling. From the image we can clearly see how a house can benefit from solar gain, however we need to understand the underpinning principles. Orientation is a key concept in maximising solar gain. Ireland is located in the northern hemisphere, which means that the sun rises in the east, is at its highest point in the south, and sets in the west. Therefore, to maximise solar gain, a dwelling should be orientated so that its long facade or longest side is within 30 degrees of south. This south-facing side of the dwelling should have maximum glazing, while the glazing on the northern facade should be kept to a minimum. The glazing used should be triple glazing with a low E coating and a thermally broken frame. Room layout is important to achieve maximum thermal comfort. So the rooms that are used most, such as the dining room, living room or kitchen, could be situated on the southern side of the house, while the rooms that are used least, like the toilet or utility, could be situated on the northern side. Rooms such as bedrooms could be placed on either the east or west side of the building. If a bedroom was placed on the east side of the house, then it would receive the morning sun, while if it was placed on the west side, then it would receive the evening sun. Shape and compactness is very important when designing a dwelling. The plans should be narrow and the shape as simple as possible to allow maximum solar gain. Complicated designs often result in extra thermal bridges and larger energy consumption. Next, we are going to examine the effect the sun's path can have on thermal performance. In this image we can see the difference between the path of the sun in the summer and the winter. In the winter the sun is lower in the sky but further away, and as a result of this it provides less solar energy. Hence it is vital that large amounts of glazing are on the southern side to maximise this light and heat gain. In the summer the sun is higher in the sky and at its closest. The solar gain is so effective it puts a passive house at risk of overheating. A passive house is a method of construction which is most likely to overheat due to its large amount of glazing on the south facade to maximise solar gain, excellent levels of insulation and airtightness level of 0.6 air changes per hour. To prevent this occurring, passive houses often use a roof overhang or a brise-soleil on the southern side of the house to provide shade when the sun is at its most intense. In this image we can see how a passive house can utilise a roof overhang to prevent overheating by blocking the afternoon summer sun from entering the house. In this image there is also a label called high thermal mass. This refers to a material, for example concrete, which can store the heat energy and release it steadily throughout the day, which improves thermal comfort and helps to prevent overheating. Another option to prevent overheating is the use of a brise-soleil. This brise-soleil again works on the same principle as the roof overhang, preventing the afternoon summer sun from overheating the dwelling by shading the south side of the house, while also ensuring that the sun can shine deep into the house when it's not at such an intense heat. The last aspect of solar gain which is common in NZEB and Interfit construction is the use of solar panels. These are usually placed on the south side of the roof for optimum performance, but could also be placed on the east and west side of the roof. The first type is the evacuated tubes. These are used to heat between 40 to 60% of hot water needs. The second type of solar panel is the PV or photovoltaic solar panel. This PV panel is used to make electricity for the house, but before this electricity can be used, it has to go through an inverter as it needs to be changed from DC direct current to AC alternating current. If excess electricity is made, it can be stored in batteries. These are just some examples of how modern construction methods use solar gain to maximise the energy efficiency of dwellings. Thanks for watching.